Hello, welcome. Let's try to solve another Leetcode problem. 3082, find the sum of the power of all subsequences. This problem is a little bit confusing, but after you understand the problem, maybe you're gonna think, oh, this is gonna be a really easy problem. Maybe it is not so hard. Yeah. So let's first try to understand it. So we are giving an integer array of nums. So this is our nums array, and we are also giving a positive integer k. So this k is gonna be a positive integer. And we need to understand the definition of this one. So the power of an array of integers, the power of the power of this array nums is defined as the number of subsequences with their sum equal to k. So we're gonna find how many subsequences. So for example, if our current subarray is 1, 2, 3, and we're gonna find how many subsequences. So it can be 1, 2, because 1 plus 2 equal to k, 3. And we can also have another one, it's gonna be 3. So how many of them? It's going to be 2. But this is not the final answer. So the final answer is the sum of the powers of all subsequences of nums. So we need to find all subsequences of nums. So if you are going to solve the problem directly, you might find it's going to be difficult. It's something like we need to find all the enumerations of the subarray, and inside each of the subarray, we need to use a 0-1 knapsack to solve the problem. Yeah, definitely this is too hard for us. And a new idea comes from this problem is that why we just fix the subarrays. So for example, if our subarray is 1, 2, 3, can this be fixed? Yeah. So this means can we find some numbers inside this nums array whose sum going to be equal to 3? So for example, can we find something like 1 and 2 because 1 plus 2 equal to 3? So this is one of the subarrays. Yeah. Can we find another subarray? For example, it is 3. Yes, we can. So we can use the 0-1 knapsack directly for this nums array, and we can find some subarrays like 1, 2, or like 3, so whose sum going to be equal to k. But how many of them? There are 2. But this is not the final answer. The final answer is that we're going to use this 1 and 2 to find a superset. So this is only a subset, but we need to find all the possible cases with this 1 and 2, and all the possible cases with this 3, and how many of them? So for this 3, this is easy. For this 1 and 2, this is going to be easy. How many of them? And we're going to include the 3 inside. This is okay. This is going to be a superset. Another one is that we're going to include an empty set. So how many of them? There are 2. So what about this 3? We just need to check how many subset of 1 and 2. So there are 4. It can be empty, or it can be 1, or it can be a subset of 2, or it can be include the subset of 1 and 2. How many cases? So it's going to be 4. So this means how many of them? It's going to be 2 to the power of some number. So this is a 2 to the power of 2. So this 2 is just the length of the nums array, 3 minus the length of our current array. So 3 minus 1, it is 2. 2 to the power of 2, it is 4. And for this one, it is 2 to the power of 1, so it is 2. So how many of them? It's going to be 6. Yeah, so this is going to be an easy problem, because we're going to turn this hard problem to an easy problem. Definitely it is not an easy problem, it's going to be a medium problem here. So first of all, we're going to find a set, it's going to be 1, 2. So this 1, 2 is going to be found from this 1, 2, 3. And then we're going to expand this subarray. We're going to let it become a superset. So the superset is that we're going to include 3, not include 3. And basically, we're going to use the mathematical idea, the combinations to solve it. If we find 3, it's going to be 2 to the power of 2. If we find 1 to 2, it's going to be 2 to the power of 1. Yeah. Now let's just use a very basic pattern of 0-1 knapsack to solve the problem first. So we're going to start from index I, and we need to check the total sum of all the values. So if this t, the total sum is more than k, it means it is not possible, so we're going to return 0. Otherwise, we're going to check this I, if I equal to n, so we're going to return a 1. So this means we find 1. Yeah, so this is just a basic pattern, and then we're going to just change this 0-1 knapsack a little bit to solve the problem. Yeah. So if our target equal to k, else we just need to return a 0. Now, we want to find all the different cases, so let's just write the 0-1 knapsack. So for the first, we will not take it, and we're going to plus something, we're going to take it. So this is going to be t plus a value, if we take it, what's gonna be the value? Yeah, so the so if we take it, so the values are gonna be nums I. And now let's just try to solve it. Let me just prepare a mod, because we need. Let me first prepare n gonna be length of the nums. So this is for this n, the length of the array. And let me just prepare a mod. So the mod is gonna be 10 to the power of 9 plus 7. And let me just return the DFS with 0 and 0. Yeah. So this is a very basic pattern of 0, 1 knapsack. So if the nums array is fixed, if we find this is our nums array, and we just want to find, we can find 1 and 2, it's gonna be 3, 1 plus 2, and we can find 3, it's gonna be the 3 equal to this k. Yeah. So normally for this kind of case, the answer is gonna be 2. We just want to check if the answer can be 2 or not. Yeah. Let me just run it to have a basic check. Now let's just check the first example. So inside the first example, it is a 2. It is okay because we didn't find all the superset yet. We just use the subset. We just find 1 and 2, it is equal to 3, and we find 3, it is equal to 3. This is okay. But this is not the final answer, but that is okay. Let's just check for another case. For the second case, it is still 2 because we find something like 1 and 2 and 3, it equal to 2, and this 2 and this 3, it's gonna equal to 5. This 2 and this 3, it's gonna equal to 5. So how many cases? It is 2. So this is also okay because our subarray is fixed at the moment. Yeah. Let's check the second example. And the sum of them are going to be 7, but as you can see, this is not possible because 1 plus 2 plus 3 is going to be equal to 6, but not 7. Yeah. Now we're going to change a little bit of this one to solve the problem. Yeah. But if we are going to use mathematical skills, I mean combinations, we have to know how many numbers are selected, because how many numbers inside the array is going to be n, and we also need to know how many numbers are selected. So inside, I'm going to prepare a selected. So this just means how many numbers selected. So I'm going to prepare 0. So for here, if not selected, it's going to be itself selected. But if we select a number, what's going to happen is we're going to update the selected. Yeah. So the selected would plus 1. Now, for here, if I equal to n, definitely we want to return how many combinations. So for example, if we select 1 and 2, how many combinations? There are 2. We can select 3 or not select 3. We just need to find how many superset. Yeah, we can find 1, 2, 3, or we can find 1, 2. So for here, we just need to change it to 2 to the power of n minus the selected. It is just a very basic mathematical formula, and we use the combinations to check. If we select 1 and 2 for this 3, we can select it and not select it. How many combinations? It is 2 to the power of how many numbers are left behind. It is 1. 3 minus 2, it is 1. Yeah. Now let me just run it to have a check if it works. Now as you can see, it passed all testing cases. And you can also say that the program is not so difficult. We just added a selected, and we're going to use the mathematical skills combinations to solve the problem. We just need to find the superset. Now, yeah, let me just run it to check if it works. It didn't work because this is a too big number. The final result is going to be modular mod. Let me just add this testing case and run it and submit it to check. It seems it works, and let me now submit it. Yeah, now as you can see, it works, and I think the speed is okay. It is just less than 1 second. Now let's just analyze the time complexity. So for the time complexity, we're going to check the first variable I. It's going to be 100, and for this t is equal to k. It's going to be 100. And what about this selected? So the selected it determines how many numbers are selected, because the array, the length of the array is 100, and we're gonna need to time another 100. So the final time complexity is gonna be 10 to the power of 6. That is why it's so fast. Yeah, I think that's all about it. And definitely this is a very good 0-1 knapsack problem. Thank you for watching. See you next time.